All right, students, welcome to review lecture. Actually, is it 9 already? 9, right? So lecture 9. Uh, in this lecture, we're going to talk about functions. So function is really important tool that we're going to use this semester. So let's try to define function. So we're going to define function. So basically, a function is a rule that assigns to each element of a set A, and we're familiar with sets, one and only one element in a set B, where set A is called the domain, and the set B is called the range. Maybe uppercase T and uppercase R. So basically, first type of explanation that we should give is to say that function works like a black box. So for example, if you were in a circus, a magician has a black box. So he puts rabbit in, but then the bird flies out. All right, and the rabbit that we put in we will call X, and the bird that flies out we will call Y. And so basically, this black box does the following: you have some set of items, you have some set of items in this set over here, and this set is called A, and you have set B also with items over here. So you take a function and you apply it to an element in the set A and gives you an element in the set B. And the main thing that in this definition that it has to be one and only one element in a set B. Only one, and cannot be two elements in a set B. So basically, you cannot have something like this. You cannot have a set A with some items here and set B and some items over here. And you take, once you apply the function to this item here, you get one value, but then second time you apply it, you get this value. So this wouldn't be a function, because for one value in A, it assigns two values in B. All right. So I use this notation f of x, but I didn't really explain what it means. So maybe that's the time to explain what this f of x means. So basically, I would say this: if x is in set A, and in mathematics we write like this: x, all right, and this symbol means belongs with as X belongs to A, or X is in A. X is in A. Right, and we already used these symbols for set. So if X is in A, then the element F, let me fix it. The element that F associates with X is denoted by F of X, and is called the image of X, under F. Or we can think of it as the value of F at X. We can think like this. So now I use the words domain and range over here. We use domain and range, but let's describe it a little bit in details. All right, so we'll say that the set of all possible values of f of x as x varies over the domain is called the range of f. So the set on the left in our pictures we usually call domain, and the set of outputs on the left we usually call the range. All right, so basically f takes a value in the domain and assign exactly one value in the range. This is x and this is y. All right, and usually we say y equals to f of x. Usually we say y equals to f of x. Okay. So we discussed the range. Let's give some comments about the domain. The domain consists of all members for which the formula makes sense. And at the same time, it yields a real value. So basically, whatever makes sense, and you can plug into this f of x and get some value for y, this would be the domain. So how do we find the domain? That's the next question to discuss. So let's do a few examples and see in practice how it works out. So the first example we're going to do, we're going to pick up some function g of x, which is the square root of x minus 7. The assignment tells us find the domain of g. Let's accomplish this task. So we're looking at this expression, and we know that we cannot take a square root of a negative number. So we know that the inside of the square root has to be greater or equal than 0. Why 0 is fine? Because square root of 0 is 0. Because 0 squared is also 0, so it works out nicely. So what we have to do, we have to take the inside x minus 7, and we have to set it greater or equal than 0. But this is our standard inequality that we learned how to solve in the beginning of the semester. So let's try to do that. So we're going to add 7 to both sides to get that x is greater or equal than 7. So we put our real line over here. We put the value 7. We have to take everything on the right side of 7. So in the interval notation, we can say that domain of G is bracket 7. We include 7, right? 7 is fine because if we plug in 7 over here, 7 minus 7 would be 0, and square root of 0 would be 0. So it would work. So from 7 to positive infinity, and for infinity we always use parentheses. But since domain is a set, we should also be able to give it in a set builder notation. So these are the all values of x such that x is greater or equal than 7 and less than positive infinity. And this concludes this exercise. So we move on to the next one. In the next example, we have to find the domain for the following function. So let's find the domain for the following function. F of x is equal to 1 divided by x minus 1, x minus 3. Oh, let's say x plus 3, since 1 is a minus, 1 would be a plus. All right, the assignment tells us find the domain of f. So what do we know about domain here? Everything makes sense unless we divide by 0. So that means we don't want to have 0 in the denominator. All right, so let's try to find places where denominator is equal to 0. So we'll take x minus 1 times x plus 3, and we're going to set it equal to 0. But this implies that the product is equal to 0. The product is equal to 0 when one term is equal to 0, or the other term is equal to 0, or maybe both at the same time equal to 0. Here it wouldn't be possible, but sometimes it happens. So we take x minus 1, we set it equal to 0, we add 1 to both sides, so we get x equals 1. It's one place where denominator is equal to 0. All right, and then we put or, and we say x plus 3 is equal to 0. So we have x plus 3 equal to 0, so we're going to subtract 3 from both sides, and we get x equals to negative 3. Thus, we have two different places where our denominator is equal to 0. So if we take a real line, and we plug in negative 3 on the left, and I use an empty circle because I cannot use negative 3. And then I plug in positive 1 on the right, For me, everything is good for the denominator except -3 and +1. So we'd like to include all of these red pieces, excluding -3 and excluding 1. So how can we do that? How can we do that? We have to say that the domain of S is, so what is this first piece over here? It starts all the way to the left at -infinity, and it goes all the way to the -3. Now this piece in the middle, it starts at -3 and it goes to 1. And the last piece starts at 1 and goes all the way to infinity. But we can't really have these disjoint pieces, so we have to join them together somehow, and we have to use the word OR. And remember, word OR is the same as a union, symbol for sets. This is set, set, and set. So union and union. So we have a union of 3 sets. Union of 3 sets. All right, so let's do one more exercise to reinforce this idea. So one more exercise. So in this example, we have to find the domain of h of x, which is equal to 1 over the square root of 2 minus x. All right, so in this exercise, we have a fraction, but at the same time, in the fraction, we have a square root. So that means we have to consider 2 things. One is the denominator is not equal to 0. And second one, inside of the square root, we have values that are greater or equal than 0. All right, so basically one thing that we have to think of is square root of 2 minus x is not equal to 0. But in order to find the place, we have to set it equal to 0 first, square both sides. So when we square both sides, we get 2 minus x is equal to 0, and we can add x to both sides. So this tells us that 2 is a bad place. So x shouldn't be equal to 2. So x is not equal to 2. All right, second thing we have to worry about is the inside of the square root has to be greater or equal than 0. So if we add x to both sides, we're going to get 2 is greater or equal than x. Or if we want to write it in a nice form, we can say x is less or equal than 2. So this tells me that I have to start at 2 and go all the way to the left. So now I have to combine this together with this. And this tells me I can't really use number 2. So what I should do, I should put an empty circle over here, because if I use 2, then I will get 0 in the denominator of the function. So finally, my answer is that the domain of h is from -infinity all the way to 2. Right? So just to summarize, we have to worry about denominators because we can divide by 0, and we have to worry about even roots because we can't really take an even root of a negative number. And to summarize this lecture, one more little thing about the variable x. So if x is usually called an independent variable, and it varies over domain of F. F of X varies as X varies. So F of X is called the dependent variable. So our notation therefore is y equals to F of X. And small example to finish the lecture. Is if F of X is equal to X cubed plus 2X minus 3, X is independent variable. And y, which is equal to F of X, which is equal to X cubed plus 2X minus 3, is dependent variable. And this is probably a good place to stop before we do some graphing. See you in the next lecture.